Very good afternoon to one and all. My name is Dr. R. Satish Kumar. I am working as Assistant Professor in SRM TRP Engineering College. Today we are going to see about the topic of Industry 4.0. So now we are in the era of Industry 4.0. So today we are going to see the industrial evolution, how the industry has evaluated, and what is meant by fourth industrial revolution, and what is the need of Internet of Things, and what are the types of uh, microcontroller available in the Arduino, and then IoT job opportunities and IoT skills. These topic we are going to discuss today. So this is the industry evolution. We are in the era of industry 4.0. Now we will start from the industry 1.0. At the end of the 18th century, the industrial revolution 1 has started. At the time of 19 beginning of 18th century, they have introduced some mechanical production machines powered by the water and steam. At the time, we uh, we have adapted the use of water by generating the steam. We generated the electricity, and then for transport purpose, we have used the electrical and mechanical machines. At the end of 18th century, we have ended the industry 1.0. After the beginning of 20th century, the industrial revolution 2 has started. Now, the introducing the mass production of lines powered by the electrical energy has been introduced here. So this is the era we have called industry 2.0. And then beginning of the 17th century, so 1970, the industrial revolution has three started through the use of electronics and IT. Further progression in the autonomous production has been used here. And then now we are in the era of industry 4.0. The industry 4.0 is nothing but based on the hyperphysical systems. We adapted to use the internet along with the machines. The machines are controlled by the internet, and then hyper system. We can call it as industry 4.0. So this is the level of complexity we have started from industry 1.0 to 4.0. Okay, so there are previously we have used as three phases of industry revolutions. So first one is nothing but 1716 to 1840. We have used the mechanical production for the purpose of railways and steam engine. We have used the industry 1.0, and then in the era of industry 2.0, 1817 to 1940, we started to use the mass production and electricity for the assembly line we have started. And then third era is nothing but 1962 2010, we started to use the computer, semiconductor, mainframe computing and personal devices with the help of internet. So this is the three earlier phases of industrial revolution. So this is very important. Before 2006, there is no iPhone and there is no iPad, there is no Kindle, there is no 4G, there is no Uber and Airbnb, Android, like that. All the advanced features are does not exist in the 2006. After the era of internet, we have started to use 4G and 5G, like that. The internet has evolved very much in our life. So this is the thing. Time to reach 100 million customers. A telephone has taken at least 75 years to reach the 100 million customers, and then a web it takes around 7 years, and then Facebook has taken only 4 years. After the introduction of Instagram, it takes only 2 years to reach the 100 million peoples. And one more interesting thing is the Pokemon Go game is it is very reachable in customers within the month of one month. So in that way, the internet has adapted for us very easily, and then our work will be completed by the help of internet. So that's why we need to go for the Internet of Things. So this is the evaluation of desk 1980 to 2014. Okay. So the industry 4.0 has some design principles. So these are all the design principles of industry 4.0. Interoperability. First one is interoperability and virtualization and decentralization, real-time capability and service orientation and modularity. So this is the 6 design principles of Industry 4.0. So it have all the 6 properties. So that's why we can call it as Industry 4.0. So the first point is nothing but the ability of hyperphysical systems. That means in the workpiece, carriers, assembly station, and products. And humans and smart factories and connect and communicate each other via the Internet of Things and Internet of Service. So by the use of Internet, we easily communicate the devices with the help of internet. So this is the interoperability characteristics. And then virtualization. So without going to inspect the machine, we can easily a virtual copy of factory. We can easily get the details about the machines or factory. So this is possible by the augmented realization and AR, VR, like that. New technologies will be there. So this is the one of the design principles of Industry 4.0. Then the another third point is nothing but decentralization, which is nothing but the ability of hyper physical system within the smart factories to make the decision on their own. So this is the decentralization property. And then fourth point is nothing but real-time capability, the capability to collect and analyze the data and provide the insights about the data very immediately. So this is the very simple problem in the simple characteristics of the Industry 4.0. And then fifth one is nothing but service orientation, offering the services in the terms of hyper physical systems, human and factories via Internet of Services. So every point is connected with the Internet of Service. That is a very important thing. And then last one is modularity. That means physical adaptation of smart factories for changing the requirement of individual modules. So we can easily change the individual module with the help of internet. So this is called modularity. So these are all the 6 design principles adopted in the Industry 4.0. Okay. After adopting the Industry 4.0, what are the building blocks of Industry 4.0? Here, the autonomous robots, simulation, horizontal and vertical integration, industrial Internet of Things, that means IIoT, hyper security, additive manufacturing. That means example for the additive manufacturing is nothing but 3D printers, augmented reality. We can call it as AR, and then big data analytics. So here the every Industry 4.0 things are connected with the internet, and then we need to store all the data. So that's why we need to go for the topic of big data analysis. Okay, so these are all the building blocks of Industry 4.0. Without those factors, the Industry 4.0 will not complete. Okay, so after the implementation of Industry 4.0, there are some potential implications are there. That means already we have discussed the robot assisted protection and predictive maintenance. So when we need to maintain the factory or maintain the mission, so that is nothing but in the augmented reality and virtual reality, we can call it as predictive maintenance, and then additive manufacturing for the complex part. So this is very needed point in the Industry 4.0. So if we need to collect some 3D model for a one device, if you go for the traditional method, it requires lakhs and lakhs. But in the 3D printers, in the hundreds, we can easily manufacture the additive devices with the help of 3D printers. And then machines as a service, and big data, drive quality control, production line simulation. So before we going to use the hardware, we need to take some simulation part that will be conducted in the help of Internet of Things, and then smart supply network. So these are all the potential implications of industrial Internet of Things. Okay, so this is the data available in the Amazon. So 2013 they have used nearly only 100 robots in their factory, and 2014 they have introduced some additional robots, nearly 10,000 to 15,000 they have used. And then in 2015 the amount will be double, so nearly 25,000 to 30,000 they adopted robots instead of humans. And then 2016 the data was very high, nearly 40,000 to 45,000 robots have been working in the Amazon. So this is the data in US. They are working in the robots in US warehouse. So already the Siemens started to work on the Industry 4.0, they are working in the parts of artificial knee, hip joints, in the medical field, like that. They are started to use the industry 4.0, and then this is the company called Trump. They also started to work on the concept of social machines. Each component is a smart that knows what work has already been carried out. So this is the very very important point, because the production facility already knows its capacity utilization and communicates with their facilities. So the production options are automatically optimized. This is the important thing in the industry 4.0. Okay, so what are the technical skills we need in the era of 2020? What does not needed in the 2015? So the order will be changed here. In 2020, the complex problem solving has increased. That will comes under the point number 1, and then critical thinking will be second, and creativity, people management, coordinating with others, emotional intelligence, judgment and decision making will be the 7th, and service orientation, negotiation, cognitive flexibility. So these are all the points we needed for the industry 4.0. So this is nothing but top 10 skills. Okay, but in the before 2015, the order will be changed. So the creativity will come under 10, but in the industry 4.0, the creativity in the third point. So like that, the order will be changed. Our thinking also changed. Like that, the industry 4.0 has grown. So this is the definition for Internet of Things. Okay, so Internet of Things is nothing but describe the network of physical objects. Okay, all the objects are connected in the internet. That is, things or objects that are embedded with sensors, software and other technologies for the purpose of connecting and exchanging the data with other devices. For example, here lot of devices are connected with the internet in the bidirectional way. So everywhere it is connected, including people, process and data and things. Okay, more than 10 billion devices will be connected in the year of 2020, and 22 billion will be in the year of 2025. This is the data available. Okay, so how the architecture of IoT will be there? So this is the architecture: internet, and then IoT gateways are connected with the sensors and controllers. Okay, connected via with the help of Wi-Fi or LAN or WAN. Okay, so before we going to see the devices of Internet of Things, we need to know about what is microcontrollers. The microcontroller is nothing but a small scale computer along with the generalized programmable input and outputs. So these are all the microcontrollers have been used in the examples of washing machine and microwave oven. The inputs and the outputs can be manipulated with the physical world. Okay, this is the example of microcontroller. Name is called Arduino. Arduino is an open source electronic prototyping platform based on the flexible and easy to use hardware and software. So it is intended for artists, designers, hobbyists and anyone interested in creating the interactive objects or environment. Okay, why we need to go for the Arduino in the purpose of Industry 4.0 or Internet of Things? Whatever the reason, the Arduino microcontrollers have been become the standard to make the magazine features many projects along with the Arduino microcontrollers. That means it is very easy to use, and also the usefulness. Programming language C is the major obstacle here, but in the Arduino C is nothing but a greatly simplified version of C++. Also, the cost of the Arduino is very very cheap, that is inexpensive. Okay, so these are all the types of Arduino: Leonardo, Node MCU, Duo, Micro, Lilypad, Explorer, Uno. These are all the type of Arduinos. Okay, thank you.